Hello, grade 9s. Okay, we are in our next section of our geometry unit, which is an introduction to circles. So far we've been talking about all of these different angle properties, notation for lines and line segments, talking about triangles and all of those different things. And a lot of the examples we've done where those properties, those notation pieces were done inside of a circle so we could get used to it. We really haven't talked about circles much themselves. So today we're going to introduce some new terminology, some new information about circles themselves. Now, I'm sure you know what a circle is, but a circle is any closed shape made up of all of these different points that are the same distance from the fixed point called the center. So if I take a look at this circle, and we're going to say that center point is labeled with point A. And remember, points are labeled with capital letters. And I whipped out a ruler. This distance would be the same as this distance, would be the same as this distance, would be the same as this distance. And this is actually how a circle is formed, right? So if I wanted to measure or create the perfect circle, all I would do is I would take the same distance, measure it over and over and over and over and over again from a point outward, and I would create a new point. And I would keep on doing it until I have all of these new points around my circle, and I could connect them. And when I connect them, that's actually how a circle is formed. So that center is really, really important because the center is actually the part or that origin piece of a circle. Now, when we name circles, we name them using the center point, and it will look like this. So if I were naming a circle, specifically if I was naming this circle here, I would name it Circle A, using a circle with a point in the middle of it and the capital letter A. This would be the notation I would use to refer to Circle A. Now, when we talk about this notation, it's oftentimes that a circle will be introduced to you in a question. So I might say, consider Circle A to the right, or given the diagram of Circle B. Less likely you'll actually write this notation yourself, but just so that you know that notation and what it means, so that when you read a question, you read information, we understand what it represents. Okay. Now, when we take a look at lines and line segments and circles combined, we get a lot of new terminology pieces. So we're going to define all of these different words, and we're going to look at the picture to see how it represents or manifests concretely in that image. So first is a secant, and I can see a secant here. Now, before I even write down what a secant is, I might notice a couple of things from that picture. First thing, I'm noticing it's a line. I can tell it's a line because it has arrowheads on both sides. I'm also noticing that that line goes through the circle, right? It doesn't just, stop partway through. It's intersecting that circle. Now, that's truly what the definition of a secant is. A secant is a line that intersects the circle at 2 points. So I can see in this secant, I'm touching or intersecting the circle once, intersecting the circle twice. Okay? I'm not actually able to draw a line that intersects more than 2 times, because then it would have to be like a squiggle, right? And that's not technically a line. But here I go. So a secant is just a line that intersects the circle at exactly 2 points. Okay, next we have a chord. And for a chord, I have this purple thing over here. And what I'm noticing about the picture of that purple thing, of that chord, I'm noticing it's a line segment, right? There's not arrowheads on both sides. Right? There's distinct endpoints. It doesn't go or continue on. It starts and ends. I'm also noticing that that starting point and that ending point both happen to be touching the edge of the circle. Okay? So when we take a look at a chord, that's exactly what the definition is. So it's a line segment, so not a line, that has endpoints on the circle. Okay, next we have diameter. Diameter we have here in this red zone. And we've probably heard of diameter before. This shouldn't be so super new. But a diameter, if I'm looking at the picture, again, pretending I have no clue what it means, I'm noticing it's also a line segment. There's not arrows on either end. It's a line segment. Now, I might also notice that that line segment starts and ends on the circle, which means this diameter must also have something to do with being a chord, right? Because a chord is a line segment that starts and ends on the circle. A diameter, I'm noticing, starts and ends on the circle, but I'm noticing that it also goes through that middle, right? It intersects that middle point, whatever that point is. So, when we take a look at a diameter, it's a special type of chord, which means it's a line segment with endpoints on the circle. But this chord passes through the center of the circle. Okay, next we've got radius. Now the radius is in yellow here. When I'm looking at this radius again, I'm noticing I do not have any arrows on either end. So I'm talking about a line segment once again. Now, if I'm looking at where that line segment starts and stops, I'm noticing that it starts on a circle and ends in the middle, or vice versa. It starts in the middle, ends on a circle. But it's not going all the way through like the diameter was. It's only going half of the way from the edge of a circle to the center. Whereas the diameter was going edge of the circle to the center, and then that center to the other edge. A radius is only going from the end of the circle to the center. So R is the radius. It's actually half of the diameter. So it's still a line segment. It is not technically a chord, because remember from what we talked about a couple of moments ago, a chord has two endpoints that are on the circle. A radius only has one endpoint on the circle. This one is not. Okay. But this radius is still a line segment that connects the edge to the center. Now, if I wanted to figure out the length of a radius, and I knew the length of the diameter, I can just cut that length in half. Okay, next we have a tangent. Now the tangent is what I have in blue here. Again, I'm noticing it has arrows. If I'm looking at the picture, it has arrowheads, which means it could be a line. Okay. And I'm noticing it touches the circle, but it only looks like it touches once. Because if it touched twice, it would be a secant. But it's not touching twice, it's only touching once. So that's pretty cool. Now, when I look at the definition, it says it's a line, but a tangent can also be a line segment. It's got options there. That it touches the outside of the circle exactly once. Now, that point where the tangent touches the circle has a special name. And that special name is the point of tangency, which kind of makes sense. It's the point in which the tangent line connects to the circle. Point of tangency means that it's the point where the tangent connects. Okay. Now, you might have heard tangent before, right? Going on a tangent means that maybe you're having a conversation with someone and you're talking about a particular topic, and then suddenly you find one piece of your conversation that relates to something else, and then you just go totally off topic to that other thing that has this one connecting point. So I might say, hey, look, a tangent has one point, right? And that point is pretty interesting. Speaking about interesting points, a point of interest in Winnipeg is the Canadian Human Rights Museum. Well, actually, that's located in the Forks, blah, 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 blah. So I went on a tangent because I found one thing that the topic of the point of tangency had in common with the Human Rights Museum. And I'm like, it's a point of interest. It's an interesting point. And I totally went off topic in a different direction. So if you're ever wondering what it means when someone says they go off on a tangent, that has to do with math. That's all connected to this, where I have this line or line segment right here. If the circle is what I was originally talking about, I found one point on that circle and then I went way different. I talked about something way different than when I was originally speaking about. Okay, so it's quite a bit of definitions, right? So we have the secant, the chord, the diameter, the radius, the tangent, and technically the point of tangency. We also talked about the notation of a circle being a circle with a point in the middle, and then a capital letter that represents the name of that center point, right? So in this case, it was circle A, because the center had point A in it. Now, we're going to take a look at this example. And this example is going to talk about us considering circle C, right? That's how I would read it. And that implies that point C would be classified as the center of the circle. Okay. Now, we're going to look at this picture on the right here, and we are going to identify what a chord is in this diagram. We're going to identify what the radius of this diagram is, the secant, etc. Now, when we do that, we might have some options for what our answers could be. And I'm going to write down what those options are. But please know if it says a chord, even though you see two chords, as long as you write one that's correct, I'm happy. Okay, so we're going to take a look at a chord first. So remember, a chord is a line segment that has starting points on the circle and it ends points on the circle. So a line segment that starts on the circle, ends on the circle. So I might be looking at this and thinking, oh, AB, right? It's a line segment that starts at A and ends at B. A and B are both on the circle, so this would be classified as a chord. And if I were to write chord AB, I would just use the same notation for line segments as we learned earlier in the year. I use the two endpoints. I have the option of leaving the top blank or drawing that line segment up on top. Now, this is not the only chord in this diagram. Technically, again, like I said, there's options. Because I'm noticing there's another part where I start and end on the edges of the circle. So if I start at D and end at E, it's also technically a chord. It's a special type of chord because it goes through the center, but it's still just a chord as well. So this chord, I could also consider DE, because again, two endpoints on the circle. Now, last but not least, there is technically one more, but I want to be super explicit about it. And I want to talk about points first. So you're noticing like some points have like really specific dots associated with them, right? There's a specific dot drawn in for G, a specific dot drawn in for K, a specific dot drawn in for F. Same with C. But there's all these other points, all these other capital letters that don't have specific points drawn in. When we take a look at all of these other letters, the reason why there's not points drawn in is it's kind of because it's assumed, right? We don't typically just name a point for no reason. We don't just pick a point out of thin air and hope we're talking about that. We pick a point usually that's of interest to us in some way. So like this H, for example. Oy, oy, oy. Okay, bear with me. This H, for example, would specifically being referred to as that intersection between the circle and this line that's going through it. And D would be that intersection of the circle and that line segment. And A would be the intersection of the circle and the line segment. B, circle and line segment. J, circle and line. E, circle and line segment. Okay, so even though I don't have those points drawn in, technically, I should still be aware of what point we're referring to. Now, if I had a different letter, what letter is not used in here? Q, for example, and I put Q here. Well, there's no obvious specific spot that I would be referring to for Q. Like, there's not like an intersection that I would be like, ah, yes, Q goes here. In that situation, I would just assume it's the point closest drawn to the letter. But whenever I have some available intersection, like I do have in all of these cases, that's typically the point that we are referring to. Okay? Now, given that, remember we were talking about chords. Chords are line segments that start and end on the edges of the circle. So we were talking about these already. Technically speaking, we can also say H to J. As long as we're referring to it as only that line segment, only that highlighted portion that I just colored in. Because if I put HJ with arrows on top, that refers to the line. And a chord is not a line, it's a line segment. But if I'm talking about line segment HJ, that means I'm only referring to the portion of the line that starts at H and ends at J. And H is the edge of a circle. And J is also the edge of a circle. And the line segment that connects 2 points on the edge of the circle is referred to as a chord. So when we take a look, oh no, the purple that I liked, it's gone. That's okay, I'll live. No, I won't. Okay, bring back a purple. Okay, so if I'm talking about a chord, I also have this third option of line segment HJ. Okay, again, this question only asked us for a single chord. Saying AB would have been enough. Saying DE would have been enough. But I just wanted to talk about all of the possible chords in this diagram, just so you understand where the possibilities lie. Okay, next we're talking about a tangent line. Now, remember, a tangent is a line or a line segment that intersects the circle exactly at one point. So when I take a look for my tangent, hopefully I notice this guy over here, right? I could see it's touching the circle. It's touching the circle at point K, right? But exactly once, no extra times. Now, since a tangent can be a line or a line segment, I can refer to it as either the line or the line segment. If the question told me tangent line, I would have to use the line notation. If the question told me tangent line segment, I would have to use line segment notation. But it doesn't. It just says a tangent. So I have choice. Now I'm going to refer to the whole line just because that's what I've highlighted here. And usually when we're talking about a line, I use the two capital letters furthest from each other, 2 points on the line that are furthest from each other, and I make sure to draw the line on top. So here is tangent GF. Okay, next we have the radius. Now the radius was a line segment that connected the edge of the circle to the center. So it could be this guy. Connects the edge of the circle D to the center C. But I also have another option. So instead of saying D, C is that line segment, I could also talk about that other piece that connects C to E, the center to the edge. These are all of my radii in my diagram. If I had more, I could list them. I'm only asked for one. So as long as I have one of these two line segments, I'm happy. Next, it's asking what the center is. Well, even without this diagram, if this was not given to us, we can still figure it out. How? Because the name of the circle. The name of the circle is truly named because of whatever that center point is. So I know that center is point C. I don't need the picture to confirm that. That's what the name of the circle is based off of. So that's how I know C is the center. Okay, next we have the secant. Remember, a secant was a line that intersected the circle 2 times. So when I'm taking a look at the secant, I see this guy here. And that line has arrows, so my notation is going to have arrows. I'm going to pick 2 points on that line. Ideally, the ones from each other. But there's actually only 2 points labeled on this line. So H, J would be the perfect secant notation. Okay. Oops. Next, we want to talk about diameter. Now, when we were talking about diameter, we were talking about a chord. So it's going to be one of these, but the chord specifically that goes through the middle. So when I take a look at this, I'm noticing this guy here is the diameter. It is a line segment. So it connects the edges of 2 circles together while passing through the center. I know it's tempting to also include that center point in my notation, but we all know that line segment notation only involves 2 letters. So I have line segment DE. Last but not least, we have the point of tangency. Remember, this was the tangent line. The point of tangency is the point in which that line connects to the circle. And a point is denoted with just a single capital letter. So, point K is the point of tangency. Okay. Lots of names, or lots of definitions, I would guess. But there's a couple more that we're going to add to this lesson today. And those are 2 specific types of angles. Now, there's an inscribed angle, and there is a central angle. So let's talk about the inscribed angle first. And I'm going to look at this inscribed angle in the picture. And before I define it, I'm just going to talk about what I see. Okay? So I have my inscribed angle. Now I'm noticing my inscribed angle is made up of 2 chords. Right? I have this chord here that connects one side of the circle to the other. It's a line segment that does so. And I have a second chord here that connects one edge of the circle to another. And those chords have a common endpoint, right? They share this point here in common. So I have 2 chords that share a common endpoint, which just happens to be that angle's vertex. Okay? When we take a look at the definition, it's exactly what we're going to have. So an inscribed angle is an angle formed by 2 chords that have one common endpoint, its vertex, on the circle. So in this diagram here, the one below, I'm going to identify my 2 chords. So I have this chord here. I have this chord here. They have a common endpoint, right? Common endpoint, aka vertex. And I can go ahead and name that angle, that inscribed angle. And when I name it, I'm going to start at one end, go to the other end, or go to the vertex, and go out. So when I do that, I have angle TRD. It kind of looks like turd, but hopefully you also have a childish mind like me and thought that was hilarious. Okay, but keep in mind that when I have this inscribed angle, it is made up of 2 separate chords. They have that common endpoint, which is the vertex, and then together they make an inscribed angle. Okay, taking a look at a central angle. When I take a look at the central angle, let's see what I've got. I've got this guy here. Now, when I take a look at this, I can tell it's different from an inscribed angle. How do I know the difference? Well, first of all, I don't have 2 chords because this first guy is not a chord. It goes from the edge to the middle, not the edge to an edge. What do we call something that goes from the edge of a circle to the middle? It's a line segment. Right, we call it the radius. Hopefully you all yelled at the computer and yelled radius. Okay, lovely. So I have one radius here and I have one radius here. They also have a common endpoint, which is the center, which is their vertex. Okay, and that's how I make a central angle. Now, the nice thing about the name central angle, it kind of makes a lot of sense. It's an angle that has its endpoint, its vertex, in the center. So, by definition, it's an angle formed by two radii, which is really just the plural for the word radius. And the angle's vertex is at the center of the circle. So when I take a look at this diagram here, I have this first radius, I have the second radius, right? Both of these are radii, radius, radius. And here we have the common endpoint, aka the vertex. It happens to be in the center, which means I have the central angle. And this central angle I can also name, and I would call it SPB or BPS. However I want to name that angle, as long as the vertex P is in the middle. Okay. Now, we are going to take a look at two examples. The first one we're going to do together. The second one, I'm going to get you to pause the video and try on your own. Now, when we go through these examples, we are going to be referring or referencing all of the new terminology pieces we've learned today. And yes, it's a lot, right? There's a lot of new words. Secant, tangent, chord, point of tangency, diameter, radius, which maybe you already knew. Inscribed angle, central angle. There's a lot going on, for sure. But we are going to do our best, and if we have to flip back a page to double check that we're on the right track, awesome. And if we don't, awesome. But we're going to do our best to get there. Now, in these examples, both example 2 and example 3, we are going to draw the things based on the descriptions. So first of all, I'm told I have circle A. Awesome. All that tells me is that the center of the circle is legitimately actually point A. It's not like close and looks like it's probably could be, but I'm not sure about it. Because of the name of that circle, I am confident that A is the center of that circle. Okay. Now I am going to draw all these different things. So first of all, I have an inscribed angle. If we think back to an inscribed angle that we just talked about, an inscribed angle is made up of two chords that have a common vertex or a common endpoint that makes the vertex. When we draw this, the angles eventually, the inscribed angle is actually going to be named BCD, which is great. There's no points B or C or D on the image yet, so I can just make them up as I go. I would like you all to use a ruler. Now, if you don't have a ruler, hopefully the sub could pause the video. In the front box of the classroom, it says classroom supplies. There's a bunch of rulers there. Pause the video, grab a ruler, come back when you've got one. Okay, welcome back. I am also going to use shapes to help me do this. Now, again, an inscribed angle made up of two chords. So I'm going to draw one chord. There it is. Connects one edge of the circle to another. And I'm going to draw a second chord as long as it has a common endpoint. So I'm going to make my common endpoint there. That's an inscribed angle. Now, you can have an inscribed angle that looks way different than mine. Right? It could be in a completely different direction. Your inscribed angle could be a much bigger angle. Your inscribed angle could be a much smaller angle. It's not so much that your image matches mine, but that your image matches the instructions. So here I've drawn an inscribed angle made up of two chords with a common endpoint called the vertex, but now I have to label it as angle BCD. Now, when I do that, I can name this point B and this point C and this point D. I could have also swapped the names of point B and point D, that's fine, but C has to be the vertex because that's how we name our angles. Okay, next we have chord. Our chord was NM. I think I was using purple for chords. So here we go. Now, when I'm looking at my diagram, I don't have point N or point M anywhere on my image. So I can make any chord I want. I don't have to connect it to a letter that's already there. I'm pretty happy. So I'm going to draw any chord. Remember, a chord is a line segment that connects one edge of the circle to the other. And so I'm going to make this. Oh, I don't want a highlighter to do that. I'm going to make this my chord. Right? Simply a line segment that goes from one edge of the circle to another. And I'm highlighting it just so that you can kind of point out from the diagram. But as long as my lines are straight, I'm happy. Now, chord NM means I have two endpoints, N and M. And it doesn't matter which ones I name it, as long as I label it on my diagram, we're good. Okay, next. We have a tangent line with a point of tangency at D. Now, if I look at my diagram, I'm noticing I already have a point D, which is pretty good. It doesn't name what the line is. It just tells me it's a line, so whatever I draw needs to have arrowheads at both sides. Now, remember, a tangent line is a line that touches a circle exactly in one point, and that point is called the point of tangency. So when I draw this line, so I have the one with arrowheads, I'm going to connect. Can I move this? Maybe. Ugh, I'm just going to redraw it. When I do this, I want to make sure that my tangent line is touching the circle only once. I'm not drawing it and saying, it's pretty, oops, wrong one. It's pretty close. For example, this would not be good because I can see it's connecting at 2 points. So now it's technically more of a secant. Okay. But I'm drawing a tangent line, so arrowheads on either side. And it has the point of tangency D. Since I already had D labeled on my diagram, I cannot make another point named D. Because if I talk about point D, I can't have 2 point Ds. Not allowed. I have to pick a different letter. So that's why I have to have it in the spot where D was already located. Speaking of which, the next question asks me to make a central angle. And now I know a central angle is made up of 2 radii, right? So it connects the edge of the circle to the middle and the middle back to the edge of the circle. But it's saying that I want both D and M to be those 2 endpoints. So I need to draw a radius. I didn't want that. I want it with my pen here. Keep on opening this accidentally. There it is again. Okay. I'm connecting point D to the center. Right, that's my first radius. And I'm connecting the center to point M. That's my second radius. And I have now drawn a central angle. Because D and M were already present on my diagram, I'm not introducing a new point D. I'm not introducing a new point M. I am simply using what I already have because I have no other option. Okay, last but not least, we have the diameter. Now, when we talk about diameter, I have the name of that diameter be BK, like Burger King. Now, I already have a B on my diagram here, so I also need to connect it. The other endpoint of that is going to be K. There's no current K in my diagram, which means I could put K wherever I want. But something to keep in mind is when I draw my diameter, the diameter is a chord that passes through the center of the circle. So I can't just put K randomly here, because then if I connected B to K, it wouldn't be a diameter, it would just be a chord. So I need to make sure that that goes through the center of the circle. Okay. So again, if you had done this on your own, heck, even when I did this for an answer key for myself before I did it with you, guaranteed my answer will look different. But the key isn't for your answer to match someone else's. The key is for your answer to make sense. Did you actually draw an inscribed angle labeled BCD? Did you actually draw a chord labeled NM? Did you actually do all of these things? With one of the big things to consider is that, the point D showed up many times in this question. We just need to make sure we use the same point D every single time. Okay, there's one more example where you're drawing things on your own. Can you pause the video and come up with something, anything, that meets these requirements? Pause the video and give it a go. Okay, and welcome back. So, when we take a look at this, we are talking about circle X, right? And that means that this point X happens to be the exact center of the circle. There's no ifs, ands, or buts. It was named that way, so it must be that way. Now, I want to start by drawing off central angle. Now, a central angle is made up of 2 radii. Now, what I'm about to draw might look different than what you have on your sheet, and that is okay. But you do need to have a central angle that is made up of 2 radii, and it has to go through the center, because that's what a central angle involves. One of those endpoints has to be labeled with a Y. One of those endpoints has to be labeled with a Z. I want you to look at your work, and then I want you to look at the person sitting near you's work and see if they drew a central angle that's named YXZ. Beautiful. Next, I am going to draw a radius, and that radius is a line segment, QX. Now, I already have X in my diagram. That's the center, which is great because I need the radius to end in the center anyways. So I'm going to pick another point, Q. I can make it up. It's not already present. And I'm simply going to connect that edge point Q to the center point X. Again, it could be literally anywhere in this diagram as long as we have that radius connecting point Q to point X. Point Q to point X. Double check yours. Double check your partners. Do they have radius that connects Q to X? Okay, next we have a secant, and that secant is a line that has 2 points on it that are U and T. Now, I don't have a U in my diagram. I don't have a T in my diagram. I know a secant is a line that goes through the circle in exactly 2 points. I am going to draw any Whoa, was not anticipating that to be highlighted. I'm going to draw any line I want. Okay? It has to go through the circle and touch at exactly 2 points. Right? I see these 2 points here. And those 2 points are going to be U and T. Can you double check yours that you have a secant, a line with arrows that goes through the circle at exactly 2 points, and those points are labeled U and T? Can you also double check the person sitting near you's work? It might be in a different spot than mine, and that is okay. But can you double check? Next, we are doing another secant. Ooh, but this secant is parallel to the secant I just drew. So I need to draw another secant. Ay, Miss T, get it together. Okay, I'm going to draw another secant. It has to be parallel, so I wanted them to look pretty parallel. I have 2 points, RS. Man, if only there was something I could draw on my diagram to indicate that these 2 secants are parallel to each other. I wonder what I could draw. What do you think? Oh, good idea. Yeah, I can draw this extra arrowhead set in the middle of both of those secant lines to indicate that these two lines would have to be parallel to each other. Last but not least, I have an inscribed angle. Now this inscribed angle is named UPS. Now I already have a U, I already have an S, I do not have a P. So I am going to make an inscribed angle using the U and the S I've already got. When I take a look at the U and the S to help make my inscribed angle, remember an inscribed angle is made up of two chords. So when I take a look, I need to draw a chord starting at U. I need to draw another chord starting at S, and I need to connect those two chords together. So here I have U to what would be the middle, which I'll label P in a second, to S. And that would be my inscribed angle. Can you double check that your angle that you drew involved the U and the S that were already present? Can you also double check that it's an inscribed angle, so one that's made out of two chords? Can you also double check that your partner also accurately drew an inscribed angle? Cool. So again, lots of different terminology that we used. There's not really a lot of new notation because all of the new terminology is already a line or a line segment or an angle or a point. And we already know how to name an angle, a line segment, a point. Like the notation's not new, but there's a lot of new definitions. So that can feel like a lot, especially all at once. But the more we practice with it, the more comfortable we'll be with those definitions. But hopefully these examples made a little bit of sense. We have one more question to do. And this question is only about inscribed and central angles. Okay? So when we take a look, I have two diagrams, which means I have two examples that we're going to do here. So I'm going to look at example A and then example B. But what we're doing in all of these is we're simply going to literally name every single inscribed angle that we can see in this diagram, and then name every single central angle that we can see in this diagram. And then we're going to do the same thing. Now, one of the challenges that I find that people have is that when we get to a complex diagram, kind of like this one's a pretty complex diagram, not going to lie to you, there's a lot going on. And it's hard for us to identify all of the things when there's lots going on versus when it's just one angle or maybe two. This one's got lots of different angle options. So I wanted to talk about how we can identify inscribed angles, how we could identify central angles, and then just practice looking for them and naming them. Now, all of these angles will be named with 3 letters, okay? We're never going to do one angle naming here. Because if I'm looking at all of these points, like most of them have a lot of offshoots and it would be very vague to know. So we're going to name them always using 3. Let's start with an inscribed angle. Reminder, an inscribed angle is made up of 2 chords that have a common endpoint. That endpoint is on the edge of a circle because the end point of a chord is on the edge of a circle. So what I am looking for an inscribed angle is I'm looking for corners or vertices that are on the circle. Okay, and that's going to be, that's going to be true for both examples. For inscribed angles, I'm going to look for a vertex on the circle. And I'm simply going to take a look at a vertex and go along for it. C looks like the least complex of all of these points on the circle, right? There's only one vertex on C. There's a lot of different things going on the different letters. And when I'm taking a look, I'm looking at C first. I picked at random. It looked the least scary. That's why I chose C first. But I'm noticing I have a vertex, right? I see this corner. Now remember, to be an inscribed angle, I need to be made up of 2 chords. So I'm looking to see, is there a chord that connects C to something else? Yeah, this is one chord. Okay, what about the other direction? Yeah, this is also a chord. So those two chords together with the common endpoint at C would form an inscribed angle. And that inscribed angle would be named ACB or BCA, whatever you prefer. So I'm going to name that angle ACB. Okay, I'm going to pause just to make sure that that's soaked in. I looked at C, right, just to recap. I looked at some endpoint on a circle because I know an inscribed angle has the vertex on the edge of a circle. So I'm going to go through and eventually look at B and A and D, but I am never going to look at E for an inscribed angle because that vertex would not be on the edge of the circle. That's what I'll look at when I'm looking for central angles. Okay. Now, when I did that, I went and said, okay, does my vertex, is it formed by two chords, right? And I'm extending them, and I go, yes, it's formed by two chords, line segments with distinct endpoints on the edges of the circle, and that's how I could tell it was inscribed, and then I simply named it. Now, that is the only vertex on C, which means I'm going to move on from C, and I'm going to look at another point, B. Now, when I look at B, I'm like, okay, there's a lot of corners going on. But again, I want to see what's made up of two separate chords. So extending out from B is this chord here. This is not a chord, this is a radius. So that would not be helpful in this situation. I want to see if there's another chord that comes out from B. And there is, there's this guy. And those two chords together form an inscribed angle, and I can name it. I'm going to name it, wait, what's happening? I could name it angle DBC or angle CBD, whatever you prefer. Now, when I take a look at that corner, that vertex at B, there are no other chords that come out of B. Right? It's only BC is a chord and BD is a chord. There is not a third chord coming out of there, which means that's my only inscribed angle with the vertex at B. There are two more inscribed angles in this diagram. Can you pause the video and try for like 2 minutes looking for those inscribed angles? Go. Okay, welcome back. I'm continuing on. I'm looking at point A as my vertex. I'm looking at chords that extend out from there. So I've got this chord here. It's a line segment that attaches one edge of the circle to another. I've got this chord here. Those are the only two chords extending out from point A because this guy is not a chord, it's a radius. Which means those two pink chords together form an inscribed angle. And that angle is called angle DAC or angle CAD, whichever you prefer. Last but not least, I'm going to look at vertex D. Let's see if there's any chords that come out of there. So I have D to A as one chord. I have D to B as another chord. This guy is not a chord, it's a radius. It does not connect one edge of the circle to another. Which means my only option here is this pink angle that I've drawn, and it is angle ADB or angle BDA. Okay, before we go on to finding the central angle, I want you to pause the video and try and find all of the inscribed angles in the second diagram. And when I'm looking at that second diagram, I will let you know there are a total of 4 inscribed angles in there. I want you to see if you can find them all. Okay, give her a go. And welcome back. Okay, when I take a look at this other diagram, there's way more points on the edges. And if I'm doing the same strategy, I'm noticing that F can't be a vertex because there's only one line segment coming out of F. And for me to have a vertex, I need 2 line segments to meet. So F is off my vertex list. M is off my vertex list. L does have a vertex. K is off. J is off. I is off. H is off. So the only 2 vertices in all of my inscribed angles is either going to be L or G, because those 2 points are the only points where a vertex is present. So I'm going to look at L first, because there's only 1 vertex there. And I'm looking for chords coming out of L. So I've got this guy, and I've got this guy. These are the only 2 chords coming out of L, which means I have this inscribed angle, angle FLG. Okay, now the other vertex that we saw was vertex G. And again, looking for chords that are coming out of it. Now I have this chord. I have this chord. And I have a 3rd chord. Oh my goodness, what do I do? Solid question. Well, I take a look at any 2 chords at a time and I name them. So when I take a look, I'm going to have this angle here. I'm going to have this angle here. And I'm going to have this whole big angle here. So with 3 different chords all connected to that same endpoint, I'm going to have 3 different possible angles. So I could have the small purple one, the small green one, or the combined big blue one. These would all be inscribed angles. So I'm going to take a look at the purple one first, because it's made up of 2 chords that have a common endpoint, and that's okay. And when I name it, I have angle MGL. When I take a look at the next one, so instead of looking at MGL, I'm going to look at another pair of chords here. Look at these 2. This was, I think, what I originally had in green. But again, it's still an inscribed angle. It's still made up of 2 chords. And I have angle LGJ. And of course, I also have the big inscribed angle connecting those 2 furthest chords from each other. And that I would name angle MGJ. Okay. In these 2 diagrams, hopefully identifying inscribed angles has kind of made a little bit more sense, with the hint of looking for the vertex that's on the edge of the circle first, and then drawing chords that come out of it to help me identify those inscribed angles. Now, we also want to look for central angles. And when we talk about central angles, these central angles will always have a vertex at the center. So look for a vertex at the center. So not on the circle, but legit at the center. And when I take a look legit at the center, every single central angle, when I 3-letter name it, will always have that center point as the middle letter. And that's true in any diagram, because the center will always be that vertex in a central angle. Now, when I do this, I'm going to pick 2 radii at a time. I don't care if there's a chord running through it or something else. I'm looking for 2 radii. And I'm just going to take a look at my options here. So when I take a look at the first diagram, I have 3 different radii extending out from that central point. So I will have, just like before, I have this first angle that I've drawn with like a little pink arc, or sorry, a purple arc. I have this angle that I've drawn with a pink arc, and I have the combined big one with the blue arc. Okay, so I'm going to name those 3 angles. I'm going to name them up in the diagram, and I'm just going to drag and drop them down below. So the purple one, I have angle DEA. The pink one, I have angle A, E, B. And the blue one, I have angle D, E, B. Just pointing out that that middle point in my 3-letter name is always going to be that vertex. Always, always, always. And I'm just going to drag my answers down here. Okay, pause the video. Try finding all the central angles for the second diagram. Go. And welcome back. Okay, I'm first looking for radii that extend out of my center point. I have 3 of them. And just like before, I can take a look at the smaller angles. I can look at the big combined angle. And I could go ahead and name them. I'm going to name them up here, and I'll drag my answer down below. But for that purple one, I might have angle HNI. For the pink one, I have named it angle INK. Ooh, an ink angle. And for that blue one, I'm going to name it HNK. Hunky. Nice. Okay, and again, noticing that that central point is always going to be that middle letter in my angle. Oops. Okay, and I'm just going to drag and drop this down where she goes. Whew. Now that is all of 6.5. Lots of new definitions, not a lot of new notation, but identifying it is a challenge. So please work through the practice, ask all the questions, do all the things. But that is it for today. So have a lovely day, and I'll see you soon. Bye.